the class is called college algebra and pre-calculus because we split this into two classes. So we will continue with chapter 6 today, which is about trigonometry. So 6, 7, 8, 3 chapters that we cover here will be about trig. So let's take a look at the notes in here. But before we start going on with chapter 6 here, who is Emily Lycom? Is that Andy? Sorry, I think that's Andy's.
Hello, this is Andrew. I'm on my sister's laptop. I don't know how to change the name.
Right click on your Emily Lycom.
I got it.
Yep, change and then change it back to her. Okay, one thing I want to point out here, class, is there is no class. So there is no class for all North Hennepin Community College students on this Thursday, this Friday, and next Monday. So yes, we have class on Wednesday, but then after that on Thursday, Friday, Monday, this week, Thursday, Friday, and next week, Monday, we do not have school at all. So please don't come to school, or no Zoom, no nothing. I will, for the Monday class, I will give you guys something to watch. So please watch I will give you some videos to watch on Monday. So just go ahead and watch those videos. Those are pretty short videos. That will be something that I would really recommend you guys to pay attention and just watch what is it's about trigonometry stuff. So and understand what you do. So when you come back on the following Wednesday, you should be able to catch up with me. So these are the 3 days no school. So please don't come to school, or no Zoom in this case. Okay. So we will continue with chapter 6 today. So as I mentioned earlier on, chapter 6, 7, and 8 are the 3 chapters on pre-calculus, or in this case, we call it trigonometry. So in the sine, cosine, tangent, secant, cosecant, and cotangent stuff. So the 6.1 is the basic trigonometric stuff, which is talking about angles. So again, you need to know this before you move on to 6.2 and 6.3, you know, the rest of the chapter 6 and 7 and 8. So so the first one we're talking about is angles. So angles, everyone knows about angles. So let's talk about what is angles here. So angles is where you will have a rotating array from its endpoint. So we have what we call as an initial side. This is the initial side, okay? And you rotate it to a terminal side. This is terminal side. And the rotation that you rotate is an angle. So this is an angle, okay? So the one that the point right over here is called the vertex, okay? So angles can be measured in positive and angles can be measured in negative. If your initial side is on the x-axis and the y-axis is right on the vertex here, and your vertex in this case is at 0, 0. So if you put it in this form, this is what we call as a standard position. Okay, so we do this a lot in this class, in this chapter 6, 7, 8. When I ask you, I want you to sketch an angle in a standard position. So that is the meaning of standard position, means that you start from the x and you go, okay, to where it is, and your vertex is at 0, 0. The positive angles is where you go counterclockwise. So if you do this angle, which it goes counterclockwise, this angle is a positive angles, and we can go counterclockwise. So this counterclockwise, this angle is negative angle. So make sure you guys know the difference between positive and negative angles. Positive means you go counterclockwise. Clockwise, if you look at your clock, is a negative angle. So this is the angle piece that you need to know. And for angles, we will denote this as alpha, beta. This is alpha, beta, or theta. So we use Greek letters here. If you want to use ABC, like normal ABC, then we use capital ABC. So So we stop using small letter because small letter is usually for variables that you guys learn in the college algebra side, X and Y, those are all small letters. So to differentiate between small letters to variables and angles, so we use the big capital letters. Okay, so that is called the how we label them. And then so if two angles have the same initial and same terminal sides, we call that as a coterminal angle. So coterminal angles means that you share the same initial and you share the same terminal side. So in order for us to figure out your coterminal angles, as you know that these angles can go infinite many angles, means you keep on going more than one revolution. So in this case, your formula to find coterminal angles is theta, which is the angle, plus n times 360 degrees, where n in this case is integer. So when I say integer, integer in this case means it can be -3, -2, -1, 0, 1, 2, 3. So it can keep on going. So it can be smaller than -3, and then negative, then anything. So those are what we call as integers. Okay. So so that means your n in this case can be what happens is this n is talking about your revolution. Okay. So n in this case is your revolution. So when you pick 0 means that you only go one revolution, just normal the first revolution. When you pick n is when you pick n is 1, you get another revolution. So you're going one more revolution. Counterclockwise means this is when n is 0. So let me draw it again, the picture, so you guys can see it. Okay, so let's say this is your initial and this is your terminal. So so this is when n is 0, means you only go one circle. When this is n is 0, the green one. So if you look at the orange one, is where n is 1. So when n is 1 means you go one full revolution. Okay. When n is 2, it will go double revolution. And this is counterclockwise, is because it is positive. Okay. And now we're going to do the n is -1. So when n is -1, you will go 1 and then 2. 1, sorry. So 1. So this is n is -1. So when n is -1, you go you go clockwise one revolution more. So you go one more circle. Okay. And then when n is 2, you go double revolution. So that's what happens to it. So this is called what we call as coterminal angles. Okay. And so how do we figure out this coterminal angles? Usually I will ask you for one positive and one negative. So in order for us to find the positive one, you add 360 degrees. Okay. And when you add 360 degrees, if you will get positive, then that will be the positive. For the negative one, you subtract 360. Okay. The reason why is because 360 is one whole full revolution degrees. So that's what we call it coterminal angles. We can do some examples. So example in this case will be let's do the radian the degree here, which is here. So let's talk more about it because we haven't talked more about that. Okay, so we talk about this one. So we talk about degrees. So a degree is measured in 360 degrees, what I just mentioned here. So 1 degree is equivalent to 1/360. So it's very small, very small measurements here. Full revolution is 360. Half a revolution is 180. Quarter is 90 degrees. Okay. And this is something that you guys learn in your geometry class. If an angle is between 0 to 90 degrees, it's called acute. And if an angle between 90 to 180 degrees, we call it as obtuse angles. Okay. Two positive angles are complementary if their sum is 90 degrees. So complementary means if you add two angles up, those two angles add up to be 90. Two positive angles, angle-centric positive, are supplementary when the sum is 180. So when you add these two supplementary angles, the sum is 180 degrees. Okay, they're called supplementary. Okay, so degree is something that you guys familiar with. The unit is the degree symbol that you have. Okay, so we will talk about the radian now. So radian is something that you guys are not familiar with. So so we will talk what is radian is. So radian usually has no units. So make sure you guys know the difference between degree and units, degree and radian, because degree has a little units on top. No units. Sometimes the unit is RAD, okay, or we call it like 3 radian, okay. So so we will use just 3 radians, or sometimes we just use 3, okay. So if I don't give any degree upstairs, means it's 3 radians, okay. So what is a radian? Okay, so radian is actually measured from a circle. So let's look at a circle. Okay, a circle with the radius r. Okay, and let's say we do this. This is also radius r. So 1 radian is actually the measure of the central angle theta. So this is the theta, where the intercepting arc s is the length of the is equal to the length of radius r of the circle. So what happened algebraically, theta in this case is s over r. So that means s in this case is what we call as an intercepting arc. What is an intercepting arc? Intercepting arc is this arc, or the kind of like a circumference of a circle, but instead of the whole circle, it's just a part of the circumference. So we call that as your arc. We call it as an intercepting arc. So in order for us to find theta in this case, this theta in this case is taking the intercepting arc s over r. Okay, and this is in radian. Okay, this is in radian form. What happened is that 1 full revolution in this case is going to be 2 pi. So if you go for 1 full revolution, it's going to be 2 pi. If your radius is 1. Okay, so usually we always say the radius is 1. Otherwise, if radius is 2, you just multiply by 2, you know. So let's say your r is 1 in this case, so make things a bit easier. That means your radius is all in 1. So it's 2 pi. If you do half a circle, it's going to be pi. Okay, so if you do half a circle, the angle in this case will be pi. Okay, and if you do just a quarter of a circle, this angle is pi over 2. Okay, so so that is the radian measurement. So 2 pi, and then if you go half a circle, is pi, and then if you go quarter of a circle, is pi over 2. So in other words, if you want to convert degree to radian, we can use this conversion, that we know that either you use 90 degrees is pi over 2, because if you look at the degree, this is 90 degrees, which is a quarter, which is pi over 2. Or you can use 180 degrees, it's the same thing as pi, which is half a circle. Or you can do 360 degrees as 2 pi. So this is the conversion of degree to radian. You can use either one of this, but majority of it, we will be using him. Okay. The reason why we use him is because we don't like fractions. And if you divide this by 2, you still end up with this. This is a bigger number. So that's the reason why that we do 180 over pi. So if you want to convert degree to become radian, we will multiply this by pi over 180. Okay, so pi over 180. And if you want to convert radian to degree, you flip it. You multiply this by 180 over pi. Okay, so this is how we convert degree to radian and radian to degree here. Okay, so if you forget, I will show you a shortcut to do this. Okay, So this is called the conversion from, so if you want to convert degrees to radian, you multiply by pi over 180. Otherwise, if you want to convert radian to degrees, you multiply by 180 over pi. And as I mentioned earlier on, 360 is the same thing as 2 pi. 180 is the same thing as pi. Okay. So these are basic stuff that we will talk about. So another thing that we talk about degree in this case, which is not in this notes, is the DMS. Okay. So what is DMS means? DMS means degree, minutes, and seconds. Okay. So you see this a lot when you do the longitude and latitude in your like travel. You know, when you go somewhere else, they always give you degree, minutes, and seconds. So minute is 1 little slash, seconds is 2 slash. So we can convert degree of minutes, degree minutes to seconds to degree by taking your minutes and like your clock. How many minutes in an hour? Anyone know how many minutes in an hour?
60.
60. And so what we do with this minutes, if you want to convert this to degree, is we divide this by 60. The reason why is because every hour is 60 minutes. So every minute you have to divide by 60. And every seconds, does anyone know how many seconds in an hour? How many seconds?
1,200.
No. How many seconds in a minute?
3,600.
So
Yeah,
yep, 60, right? One minute has 60 seconds. So 1 hour has 60 minutes. So 60 times 60 is 3,600. So we will divide this by 3,600. Okay. So if you want to convert DMS to degrees, the degree is fine already because it's really in degree form. So you just take the minutes divided by 60 and you take the seconds divided by 3,600 and you will add, then you add all your numbers up. So in other words, you just do example is if I give you 7 degrees, 10 minutes and 15 seconds. If you want to convert this into degree, you just take your calculator and just do 7 plus 10 over by 60 plus 15 over by 3,600. You guys all right? What you get?
7.170.
What? 7 by what?
7.170833333.
Something like that.
Yep.
You guys okay here? Questions for me?
What is that? Like, what is the value we get?
The 7.170833 degrees. What do you mean by
Oh,
what?
no, I get that. Like, what does that value represent?
This is in degree form.
Okay.
I'm calling you to change the DMS, the degree, minutes, seconds, to degree form.
Get the degree from the 7.
So if I give you 7 degrees, 10 minutes, and 15 seconds, this is how you change it to degree form.
Oh, okay.
And the reason why you need to change this degree form is mostly majority of the formulas are in either degrees or in radians. They are not in DMS form.
Okay.
How do we go the backwards? Means how we change from degree back into DMS. So instead of dividing, you what?
Multiply.
Multiply 60. Yep. So if I give you 7.17083 degrees, we know the answer is this one, right? Okay. So how do we change this back into the DMS? So what you need to do here is the 7 degree is already there. So you do not need to do anything with it. So you take the decimals representation 0.17083333333 because that's what Kevin told me. Multiply this by 60. The reason why is 1 degree is 60 minutes. So anyone got an answer here using a calculator? How many minutes is this?
10 minutes.
10 point, what is 10 point something, right? 10.25.
25.
Okay. So this 10 is the minutes. Okay. And what you do is you take the remainder. Don't forget, this remainder is going to be in minutes now. This is minutes. This is degree because it be changed. Can someone tell me how many seconds in the minutes?
6.
So you have to multiply this by 60. Can someone tell me what is 0.25 times 60?
15.
15. So this 15 is the 15 seconds. You guys got it? So this is how we change DMS to degree and degree to DMS. Anyone have any questions for me? Okay, I want you guys to try to do this on your own. This is your notes. So question number 9, I want you to convert 330.2 degrees and 25 seconds, this is seconds, to degree decimals degree. I want to do question 9. And I also want you guys to do question 10, convert negative 145.58 degree to DMS, which is covered backwards. Go ahead, try question 9 and question 10. This is question 9, and this is like question 10. Okay, go ahead and try it your own. And these are all basic stuff, I tell you, right? And if you doesn't know how to do all this work, I just tell you that you're going to be in difficult, very difficult place in this chapter 6, 7, 8. So try 9 and 10 first. Anyone know how to do question number 9? Anyone? Convert this into DMS. Oh, to decimal. Sorry, convert DMS to decimal. Anyone? No.
I got 330.0069.
So you take 330 plus what?
25 divided by 3600.
And you get what in this case? Is it Gamal?
Yeah. 330.0069, and then a bunch of 4s.
Okay. You guys all right here? Questions with this? All right. I want you to do the opposite. Convert this into DMS, like what we just did over here. Now, I just want to point out, class, is this negative is redundant. So what I mean by redundant means remove it. So ignore the negative first. Do the 145.58. Then once you get your answer, let's say this is your answer, then you just put in the negative on it. Okay, so don't put the negative, just take it out first and then do what I just did here. And then once you get your final answer, you just slot in the negative. So it's negative 45 degrees. Anyone know how to figure out your minutes?
Times by 60.
Kevin?
Times it by 60.
Time what's by 60? What number should we multiply by 60?
0.58.
Yep, that's right, Andrew. So you take the decimals, not the whole thing, just the decimal 0.58, you multiply by 60. Andrew, what'd you get?
34.8.
So what is your minutes in this case?
34.
Yep, 34.
Mhm. And now how do you find your seconds?
Times by 60.
Again, what by 60? What number?
The 0.8.
The 0.8, the leftover 0.8, you multiply it by 60, which gives you what?
48.
48. And this is your minutes. And this will be your seconds. So that means your answer in this case will be 30, what negative? So you just put in a negative. Negative 145 degrees, 34 minutes and 48 seconds. You guys all right here? Questions so far? Easy? All right, next, let's talk about the first example. We skip around, so go back to first. Can you convert this into degree for me? Can someone convert number 1 into degree for me? Anyone know how to convert the first one into degree?
Times by pi over 180.
No. This is DMS. Remember, it looks like number 9.
257.5.
Yep, this is 257.5 degrees. Okay. So the question here wants us to do what? Sketch each angle and determine the quadrant. You guys know the quadrant, right? How does the quadrant works? Anyone know? Where's quadrant 1, 2, 3, 4 at? 1 is at
Top right.
top right. 2,
Bottom right. And left right.
left to the top left. 3, bottom left. And the last quadrant is the fourth quadrant is the bottom right. Okay, this is fixed. This 1, 2, 3, 4 quadrant is fixed. So can someone tell me where is 257.5? You draw it. And don't forget, you have to start from the x-axis. This is the way you start. Always you start from the x-axis here. So this is positive. So we go counterclockwise. So where is 257.5?
In the fourth quadrant.
Quadrant 4.
Yep.
So if this is 0 degrees, this is 90 degrees, right? What is degree is this one?
180.
180. What is the degree for this one?
240.
Not 240.
270.
This is 270. And then this is back to 360 here, right? So can someone tell me where is 257.5? Quadrant
3.
Quadrant 3. And how do you draw it? It's somewhere over here. And this is a terminal. And then make sure you go what? Counter clockwise. You guys all right here with the first question? I want you guys to do negative 600 degrees. Negative 600 degrees. Again, we start at the initial site. Then tell me what quadrant belongs to. Anyone know how to do negative 600 degrees?
Will be in quadrant 2.
How do you know it's quadrant 2?
because you have to go the other way clockwise.
Like how many times, Kevin?
2.
Like this?
Yep.
That would be wrong. You didn't go all the way. So this negative 600 degrees is actually go more than one revolution, right? So you have to add what? 360 degrees. So what is negative 600 plus 360?
240.
Negative 240. So if you go backwards, this will be 0. This will become negative 90 degrees, negative 180, and negative 27. So you just need to go backwards now. And then this is negative 360. So for this case, negative 240 is where you go one revolution. Don't forget, because of the 360 here, you have to go all the way. And then you have to go all the way around one. So this is negative 600 degrees. And this is in quadrant 2. You guys all right here with this? Questions? All right, next is 7 pi over 5. Now this 3 and 4 is in radian because you don't see any degrees. And sometimes when you hear the word pi is involved, usually automatically it's in radian form. So if you put this in the units in the angle, last time we saw, right, 0, 90, 180, 270, 360, right? So this will be 0. This will be pi over 2. This will be pi. This will be 3 pi over 2. And this is back to 2 pi because that's full circles. So where is 7 pi over 2 in this case? 7 pi over 5. Where is 7 pi over 5? Anyone? What quadrant belongs to? So what we do here, so if you doesn't know how to do this, so hey, oh, someone say something. This is in quadrant 3. Very good. That is correct. Me. Some of you who do not know this, pi in this case means they have them the same. So if your denominator is 5, so this is 5 over 5. So we change everything over, try to change it to 5. So, so 7 pi is more than 5 by 2. So that means that this is going to be in quadrant 3. So it will go all the way to quadrant 3. Okay, so this is 7 pi over 5. The reason why is because from here to here is 5 over 5 pi. So if you want to 7 pi, this will be increased by 2 pi, 2 over 5 pi. So it's a little bit more than here. So that's why it is in quadrant 3. You guys all right here? Now, question 4 is a little bit special. It's because in question 4, they give you 6.02 radian. It's different from the question 3, although they are in radian, because question 3 is in terms of pi. This is not in terms of pi. So when you do this, you have to convert all this pi into 3.142. So we know this is 0. So what is 3.142 divided by 2? Anyone has a calculator? You can use pi symbol. So I'm going to use the pi symbol. You guys have a pi symbol. So you take pi over 2. So this is 1.571. This is 1.571 here, which is the same thing as pi over 2. This is 3.142, which is the same thing as pi. And then the other one is 3/4 of it. So 3 times pi divided by 2. So that is 4.71. And then back to here is 2 pi. So you multiply 2 times pi. That will give me 6.283. So my question to you is, where is 6.02? When you use this as your x initial point, what quadrant it belongs to?
Quadrant 4.
Quadrant 4, yeah. So this whole thing is 6.02 because the whole revolution is 6.28. This is 0.26 shy of the whole circle. So that's why this is in quadrant 4. You guys with me here? Questions you have? Tough? Anyone? Tough? Questions for me? Okay, next, determine two coterminal angles, one positive and one negative for each angle. Now, in order for us to find the positive one, you add 360. Or if it's radian, you add 2 pi. For the negative one, you just subtract 360 or minus subtract 2 pi. Depends on, so like 5 and 6, they are in degree. So we will use the 360. The 7, 8 is radian, we use 2 pi. So for question number 5, in order for me to find 300 degrees, and I want it in a positive and a negative one, so you just add 360 to this one. So what you get for the positive one? 660 degrees. So this is for the positive one. The negative one, what I do is I just subtract 360, and yes, your answer has to be negative, and this is negative 60 degrees. So when I ask for a positive and a negative, means that a positive angle means your angle has to be positive, and when I ask for a negative one, the angle has to be negative. So this is how we find the coterminal angles for positive and negative. Now, I want you guys to try to do question number 6. Negative 740 degrees. And I want you to figure out a positive one and a negative one. Go ahead and do it. Anyone know how to get the positive one?
Negative 740 plus 360 equals 380. Negative 380.
Is this the answer in this case, Gamal? No, that's not the positive one. This angle is not positive.
2 revolution.
So you have to add another one.
360.
360, and what you get?
Negative 20.
Is this a positive one?
Nope, you gotta add another one.
So what happened in class is if you add 360 and you still get a negative angle, you have to keep on adding 360 until the number is what?
Positive.
Positive. So what you get here for this case? 340 degrees. You guys okay with the positive one? Then how do we find the negative one?
Minus 360.
So there are multiple answers here because it can go a lot of revolutions. So you can take negative 740 minus 360, which give you what?
1100.
Negative 1100. So this is one of the answer. Can someone also give me another answer that for the negative one?
Plus 360.
Which will, if you plus 660, which is this one, 300 and so negative 380 degrees is also correct because that angle is negative, right? What else? Negative 20 degrees is also an answer. So that means that as long as your angle is negative when you add or subtract 360, that is the negative angles. Okay, so your answer can be negative 1100 if you subtract 360, or it can be negative 380 or negative 20. So these are the answers in this case. There are multiple answers here, but you need to give me one. I think your online homework will take the smallest negative angles. Okay, so usually when they ask for it, they want you to give you the smallest negative, not small, the biggest negative angle and the smallest positive angle. That means you do it in the first revolution. Okay, so but if you in the test, I'm not very picky as long as you give me one positive and one negative. So a lot of students give me negative 380 for the positive one, and you get it wrong. So make sure you keep on adding 360 until that number becomes positive. Anyone have any questions for me here? So this is for the degrees. Now we do the radian. So in order for us to do the radian, we don't add subtract 360, we add subtract 2 pi. So in order for us, for question 7 is 2 pi over 3. So if I want it to be a positive one, I just add 2 pi. What do I do here is I will change this 2 so that it will become a 3. So what you do is you multiply 2 and 3. So what is 2 times 3 is? 2 times 3 is 6. So you get 6 pi over 3. So this 6 over 3 is the same thing as 2 pi, which is the same thing as adding 2 pi. I'm making this the same denominator. So your answer in this case is 8 pi over 3. This is the positive one. How do you find the negative one? You just subtract 2 pi. But as you know that 2 pi is the same thing as 6 pi over 3. So the denominator is the same, so in order for us to subtract. So the negative one in this case is negative 4 pi over 3. You guys okay here? I want you guys to do question 8 on your own. Figure out what is negative pi over 2 for the positive one and the negative coterminal angle, which is number 8. Anyone got an answer? Anyone? For negative pi 12, what is a positive one?
23 pi over 12.
So you add what?
24 pi over 12.
Very good. That's the same thing as 2 pi. So you get 23 pi over 12. That is correct, Gamal. So this is a positive one. And how you get the negative one? Anyone?
Subtract 24 pi over 12.
And you get what?
Negative 23 pi over 12.
Not 23.
25.
Okay, thank you. Is that Nukin? So this is a negative one. So this is your answer for the positive and the negative one. Questions for me, class? Questions? Okay, so this is called what? Coterminal angles. That is one positive, one negative. Because you'll be asking your next test number 3, I will ask you how to do this. Number 11, you have to find the complement and the supplement of this angle, 93 degrees, and then 3 pi over 4. Now, as you know that the meaning of complement means that total should be what? 90 degrees. Supplement, the total should be 180 degrees. So if you find this number is 93 degrees, right? That is over 90 degrees. So the complement in this case, a lot of students give me -3. Because 93 take away 3, you got 90, right? I want to point out to you guys that if you read the instruction or the definitions of complementary and supplementary angles, which I will underline it, it's right over here. This has to be positive. You see that? This angles has to be positive in order for you to figure out they are complementary or supplementary. So in this case, can you have a -3 degrees here?
No.
No. So in this case, this is called DNE. That means it does not exist. Okay. So you cannot have a negative angles for complementary and supplementary. Both of them has to be positive. Can someone tell me what is the supplementary for 93 degrees? Means when you add them up, it's 180. So your answer should be what?
87.
87. Okay, so when you add this, or you take 180, subtract him, you get that. So that is how you, it's very easy, right? It's not, this is actually, it's basic, but although it's basic, easy stuff, you also need to know it. When you talk about radian, 3 pi over 4, you want to find a complement and a supplementary. Again, we will use radian. So 90 degrees is pi over 2. And supplementary is pi, which is the same thing as 180 and 90 degrees that we have. Okay. So what is a complementary for 3 pi over 4? Anyone? Nukin, Andrew, Andy? What is the complementary of this fellow? 3 pi over 4.
5 pi over 4.
No, if you, that will be supplementary, that will be pi over 4. Because when you add this, you get pi, right? But how about complementary?
Is that DNE?
This is DNE, yes. The reason why is because if you want to graph 3 pi over 4, can someone tell me what is the graph looks like in 3 pi over 4? Where was it at? What quadrant is this 3 pi over 4 at? It's in quadrant 2. So this is 3 pi over 4. Which is more than 9 pi over 2, which is more than 90 degrees. That's the reason why that this fellow is DNE here. And to find the supplementary, you just need to figure out what is this angle is. Since this whole thing is 3 pi over 4, then this will be pi over 4. Because the whole entire half circle is pi. Okay. So, so don't forget that if your angle here is bigger than 90 degrees, it is DNE. And if your angle is bigger than 180 degrees or pi, it is DNE for supplementary. Okay. Anyone, any questions for me here so far? Questions you have before we move along? Tough? Not too difficult, but you need to know this. As I told you, right, this is the basic stuff for trigonometry. All right, so we're going to talk about number 13, 14, and 15. So we're gonna do question 13 here. You have to convert these degrees into radian. So does anyone know how to convert 45 degrees into radian without any calculator? You have to multiply this with what?
Pi over 180.
Yep. The reason why it's not the other way around is because your 180 degrees is down here. So you can tell that the degree and degree will cancel out. So that's why the 180 degrees should be in the bottom, not on the top, not flipping it. Can someone tell me 45 goes into 180 how many times?
4 times.
4 times, yes. Make sure you guys know that. 45 goes into 180 4 times. So 45 times 4 is 180. So your answer should be what? Pi over 4. I want you guys to do question number 14 and number 15 on your own. Convert 120 degrees into radian and negative 60 degrees into radian. We did so many questions already. That's why in your homework for this section is quite a little bit because they're pretty simple like this. Anyone? 120 degrees in radian?
Pi over 3.
Not pi over 3. Good try. It's close. So you multiply this by pi over 180, right? So the 0 and 0 will cancel. Can someone reduce 12 and 18 become what? Come out.
2 and 3.
Yep. So this is 2 pi over 3. Yeah, you're correct. And how about number 15? Or pi over 180? Anyone? Andy? Avery? Ethan?
Would be negative pi over 3.
Yep, that is correct. Okay. So the 60 goes into 83 times. And don't forget the negative. Okay, a lot of students forget the negative in the test. You won't get it right. So this is how we convert degree to radian. So if you look at number 16 and 17, we do the opposite now. We will convert the radian to degree. Okay. So how do we convert 7 pi over 6 into radian into degree? Is we multiply this by what?
180
Over
pi.
pi. And you notice that the pi, first thing is cancel the pi is gone. And then you can also cancel, 6 goes into 180 how many times?
30.
30. And then you multiply it by 7, you get what?
210.
To 10 degrees. So this is how we convert radian to degree. So I want you guys to do question number 17. Convert this into degree. Very straight. This is easy, right? You guys should be able to do. Anyone got the answer for
Negative
negative
40,
negative what?
140.
140. And don't forget that the pi and pi will cancel, right?
Yep.
And 9 goes into 180 how many times?
20.
20. So this is why 7 times 20, if negative 7 times 20, you give us negative 140. You guys all right here? Questions for me? Pretty straightforward, right? Not too difficult. Now we're going to use your calculator. So we're going to convert this back into radian. So the reason why is because this number is decimal. So usually you need calculator. So you just multiply this by what?
Pi over 180.
Now make sure in your calculator, you use the pi symbol. So everyone, please take up your calculator. You will please find the pi symbol. Do not use 3.142. Do not use what 22/7 that you guys use in high school. No, use the pi symbol. And the question wants us to round this into 3 decimal places. So go ahead, take out your calculator and do question 18 and 19. Please do your homework. You can tell this is not difficult, right? And these are the basic stuff. And this is all from the notes, so make sure you refer to it. Anyone for number 18?
1.518.
1.518. I'll ask someone else to do it beside Kelvin. Again, make sure you have your calculator. Times pi divided by 180. Okay. Do you guys got different answer? Let me do it again. 87.4 times pi over by 180. I get different answer, Kelvin. Gamal, do you guys got 1525?
Yeah, I get the same thing as you.
525, right?
Sorry, that's what I had. Sorry.
You're fine. Do question 19. You guys know what to do here. This is not tough, right? You should be able to do this. Ethan, Andy. Where is number 19? Negative 216.35 degrees.
Negative 3.776.
3.776. Agree? Anyone? Disagree?
Yeah, I got that.
Okay, good. And then the last two questions is to convert the 20 and 21 is to convert a radian to degrees. So you have to multiply this by what?
180 over pi.
And the good thing is the pi will cancel out. So you just need to use your calculator to figure out what is 15 times 180 divided by 8 or the other way around. So the pi will be gone. Okay, this also 1 3 decimal place, don't forget. What is that? Anyone? 15 times 180 divided by 8, what do you get?
337.5.
All right, this is your attendance here. I want you to private message me for question 21. If you don't private message me, what is this answer? I will mark you absent. I don't care if the answer is right or wrong. Please, you guys know how to private message me, right? In the chat room, private message me what is -2, because the question is asking for -2. This is -2 radian. You have to convert that into degree. Private message me. What is that? Please private message me in 3 decimal place. No, Nukin, that is wrong. Yep. Andy, Henry, and me is correct. Andrew is correct. Avery is wrong. Suksa is correct. Gamal is wrong. I don't think, Gamal, check your answer again. Check your answer again. Nukin, how you get -360? No, Nukin is wrong. Ethan is wrong. I need, Gamal is correct now. Ethan is not right. Again, Ethan, make sure you use the pi symbol in your calculator. Don't use 3.142. So this is -2. So don't forget, -2 and -2 pi is different thing. -2 pi is -360, as what Nukin says. So this is not 360. Okay. So you do need to multiply this by 180 over pi. So take out your calculator and press, yep, that is better now, Nukin, times 180 over pi. So this is the answer in this case, -114.592 in 3 decimal place. Nope. Yep, I know what you're talking about, Nukin. That's why I bring it up. -2 and -2 pi are 2 different things. So please be careful with that. Okay. You will get wrong. So a lot of people, think that way. Questions for me with this one? Pretty easy, right? We'll ask you back to on Wednesday and see how far we go. Okay. So before we continue, we will talk, we just do some basic stuff. So we're going to talk about some word problems here. So we do the arc length first. So what is arc length? So arc length in this case is like a circumference of a circle. Okay. So if you have a circle, okay, an arc length S is where it is just a piece of the circumference. This is called the arc length, and the symbol we use is S. And this is your radius, and this will be your theta. We call it the central angle, theta. So in order for us to find what is the arc length S, the formula is R times theta. But you need to be careful with this, is because theta in this case is measured in what? In radian. Okay, so this theta is radian. So a lot of students in my homework and my test, they look at the theta is degree, let's say 45 degrees, they put that as a 45 degrees. You get it wrong. Okay, make sure you have to convert the degree to radian first before you plug it into the formula. So this is one of the formulas that you need to know. So this is one of the formula. I'm going to do it in blue so you guys see the formula here. The next formula you need to know is this formula, also in blue. And then the next one is this one. And the last one, there are few formulas in this 6-1. I will highlight them in blue. One is called the coterminal angles, where you take theta plus n times 360 degrees. I think you guys know how to convert radian to degree, degree to radian, so I'm not going to highlight this in blue. This formula is to find arc length. Okay, This formula is to find angular speed. I will tell you what those is later on. And this formula is to find the area of the sector. Okay, so there are 1, 2, 3, 4 formulas in 6.1. Okay, so let's talk about the arc length, because if you read the questions, they mention arc length. So we do that. So that will be question number 22. So if you read question number 22, it says that find the radian measurements of central angles with the radius of 14 feet and the intercepting arc length of 8 feet. So that's why they use the word arc length. So we use the formula S equals to R times theta. So can someone tell me where is the 14 feet goes to?
Goes in for R.
For R. And where is the 8 feet goes to?
The S.
The arc length S. So we are looking for what? The central angle, the radian, theta. So how do we solve for theta here? Divide this by 14, right? Now, pay attention here, because a lot of students do this, get this wrong in your homework. Is some students take out your calculator and did 8/14, and you give me this answer, 0.5714, something like that. You get it wrong. So in your online homework, do not use your calculator. But make sure you reduce this. Can someone reduce this for me? What is 8/14 is?
4/7.
4/7. So this is your answer here. So do not use your calculator to figure this one out, which is this one. Your online homework will mark you wrong. Okay, just want to point out to you. Some of you was like, why they mark you wrong? I will say, please write your answer in reduced fraction form. Okay. Next, question number 23 is to find the arc length given you that the radius is 15 and the central angle is 60 degrees. So where do we put the 15 in this case?
S.
15 is your what?
Oh, your radius, sorry.
Your radius. So that should be R, right? And where should we put 60 degrees?
Your theta.
Theta. So is this correct? What's 15 times 60? 900. Is this correct, class?
Don't we have to convert that to radians?
Yes, this is what I told about you guys in my test. This is where you get wrong. Okay, and the reason why it's wrong is not because you use the formula. You use the formula correctly, but this is the wrong piece. Because you have to convert this into what? Radian. So can someone convert 60 degrees into radian?
Is it pi/3?
Andrew say pi/3. Is that correct?
Yeah.
Yep, that is correct. So that means that I'm going to rewrite this. This is all wrong here. So as in this case, your radius is still 15, but your angle is what? In radian is pi/3. Now, there are two ways for you to write your answer. You can write your answer in terms of pi, and you can write your answer in terms of decimals. So if you want to write in terms of pi, you just need to reduce the 3 and 15 to become 5. So 5 pi is your answer. But if you want to use in decimals, then you just use your calculator and figure out what is 5 times pi. That would be around this 15.708. Okay. I'm not picky with your homework, with the test and everything, but your online homework is very picky. So make sure you guys read the question carefully. If the question is asking you to round this in 3 decimal places, then this is your answer. If the question did not say anything about decimals places, that means your answer is in pi form. Okay, so read when you do your homework, read the question carefully. If they say round in 3 decimal places or round in 2 decimal places, means you have to use your calculator like what I just did here. This is the answer. But if a question did not mention anything about decimal places, means it's either in terms of pi like this or in terms of fractions. Okay, so if a question did not mention anything about decimal places, either it is in fraction or either it is in pi form. So read the question really carefully and figure out. And my main part of this is a lot of students make mistake here is because of didn't combinate to radian. Now we will do the last question here, which is number 25. This is a word question. So if you look at number 25, it says that the distance between 2 cities, Omaha and Dallas, with the latitude of these two, you have to find the distance for that. Assuming that the Earth have a radius of 4,000 miles, and the cities are having the same longitude. So in this case, that this is Earth, this is a sphere, and we got 2 cities. One is Omaha and one is Dallas, and the radius of the Earth in this case is 4,000 miles. For Omaha, the unit is 32 degrees, 47 minutes, and 9 seconds. And for Dallas is no. So that's that. Sorry, this is Dallas. We write it wrongly. So because Dallas is south. So 32 degrees, 47 minutes, and 9 seconds. And Omaha in this case is what? 41 degrees, 15 minutes, and 50 seconds. I want you guys to convert this DMS into degrees. And the question wants us to find the distance, means they want you to find this, which is the same thing as S. So we need to figure out what theta is first. So how we figure out theta is you have to change this into degree. So change 41 degrees, 15 minutes, 50 seconds into degree, and same thing with the Dallas, Texas. Do you guys remember how you change this to degree?
By 60.
So it's 41 plus 15 divided by 60, and then what else? Plus 50 divided by what?
600.
3,600. So anyone know what is this answer is? Can you round this answer? Can you guys round this?
Is it 41.2638888?
Can you round it? That's my question.
41.
You cannot round it, right? So this is 41.2638888. Do the same thing for Dallas, 32 degrees, 47 minutes, and 9 seconds. So you have to divide this by 60 and divide this by 3,600. So you got what? 32.7858. 333. 785. This is the number. So how do you figure out theta in this case? So the theta in this case is where you take this 2 and what you do? You subtract it. That's why you have to minus these 2 up. So you have to take these 2 numbers and subtract it. That's how you figure out your theta. So you take this minus 41.62388, bunch of 8. So the theta in this case is 8.838. And again, you cannot round this answer. It's not your final answer yet. 8.38 at 8.838. 8.838. 055, all this weird number. However, if you look at this, because we need to find the outline, this is a formula we are using. And what do I tell you about the theta? It has to be in what form?
Radians.
Radian. So you have to do another conversion to convert this into radian. And how do you convert this into radian? You learned that already in my class today.
If we got a 2 in front of the 6 for 41 point.
I'm sorry?
For the 41.62 it's supposed to be 2 in front of the 6.
That's just a number in front of 6.
Yeah, 41.26.
26?
Yeah.
Yep.
26238. Okay, then I need to erase this fellow. Anyone got an answer on this one when you subtract this? It's going to be different, right? Anyone? 41.2623888.
8.478.
8.47655555. Something like that. You guys got something like that?
Yep.
8.476555555. And then how you convert this into radian? Multiply this by what?
Pi over 180.
And again, no rounding here. Make sure you use a lot of other decimals you have. So times pi over 180. But pi over by 180. You get 0. What? 1479. Again, no rounds. Right, this is what you get, 0.1479. So this is just to figure out what? Theta. So now you need to do the whole thing now. So we're going to use this formula. S equals to R times theta. Do we know what is the radius in this case?
4,000.
Because the Earth is 4,000 miles from the center of the Earth. Times this number, 0.1479, so on, so on, so on. So that means you take this number times 4,000. Now, this is your final answer, then you can round. So your answer should be how many miles apart?
591.7742.
Yep, so 591.77, around this. Again, I'm not picky, so 7, 8, right, around that. I'm not, it's around 592 miles. So this is your answer for this case. Questions for me. This is how we do question number 25, where the question is given you 2 cities with their latitude. Okay, so you need to convert them into degree, and then you have to subtract it to find the theta, and then convert back degree to radian. And then after that, you take 4,000 times it, and you'll get your answer here. Anyone have any questions for me here before this is the end of the Zoom class. Anyone have any questions for me? Okay. Don't forget when you guys come back on Wednesday, we will continue. We haven't talked about the last two formulas, which is the angular speed, the linear and angular speed, and the area of a sector. So area of a sector of a circle. So these are the two formulas we haven't talked about it. We just talked about outline. So we stop at number 25. So when you come back, we will do number 24 and 26. And then 27, and then 30, 28. So these are the few things that we will talk about in when you come back, just 4 questions left. And then we will start 6.2. I believe you guys got a unit circle. Remember on the test 2, when you guys leave, I give you a unit circle. Do you guys still have it with you guys?
Yep.
Yep, we will be using that on Wednesday. Okay, so I think you got the unit circle here. Which looks something like this, right? I think you guys have it. So on Wednesday, we will start using this circle. Okay, so if you don't have it, please send me an email. I will send you this print out yourself. You have to print out yourself. If you don't have it, please send me an email. I will give you this for you to print out. If you have it, just keep it on, bring it on Wednesday class, and we'll go over this together. What is this? And this is actually using 6.2. Okay, so when we start class on Wednesday, 6.2, there is no homework due on this Wednesday, so you can start working on 6.1. 6.1 homework is due on next Wednesday, so it's due on next Wednesday, which is when October 27th. So no homework due this Wednesday, but this homework is due next Wednesday with 6.2 and maybe 6.3, but 6.2, 6.1 and 6.2 for sure. So make sure you start working on your homework here. This is easy, so start working on it. Anyone have any questions for me? And I'm still grading your test on Wednesday. I will get you. Yes, Gamal, questions?
Real quick, on Cengage, it says that 6.1 is due this Wednesday, actually.
I will move it. Yep. Thank you for letting me know, Gamal. So it's not due today. Yep, I will definitely change the date. Anyone have any questions for me? Yep, I will change the due date for that to next Wednesday. Okay, if you don't have questions, you may leave. If you have questions, do stay back. And I will
Have
help
a good day.
Yep, I will see you on Wednesday class.
See you.
Yep. Kelvin, you all right?
Yep.
Have you talked to Tom about?
So he was supposed to call me the next day. He sent me an email saying he was gonna call me, but he never called. So I'm gonna try to reach him after class.
Yeah, reach him. Ask him for his phone number, and then I do have his phone number, but I don't want to give it to you.
Okay, yeah, I know. In his email, I think it even
Oh, wait,
said